of the year. I can never remember how I say, hey, what's up, bud? Well, hey, nice to meet you there, Zeke. But is Zeke short for like Zachary or what? Very cool. Hey, a zebra. Who doesn't like a zebra? Hmm? Anyway, you know what? I've always been wanting to ask a zebra this question. Since I talk to animals in the zebra talks, why not? So, I want to ask you, are you actually white with black stripes? Or are you black with white stripes? Hey, it's a serious question. I mean, it just seems, like a good question because you have these black stripes and it looks like you're white with black stripes. But, oh, you're not. Hey, this zebra is very knowledgeable. You are black with white stripes. Oh, hey. Would love to keep talking. You're a really cool dude. I'm sure we're going to see you throughout the video. But you know what? We're really here for our fourth graders. That's right. We are doing Chapter 5 review for the test. Scary. No, it's just we're reviewing stuff that we've already done. This was a short chapter, if you recall. There was only 6 lessons. So let's go ahead and get started. Woohoo! Number 1. It says list all the factors of the number. And you can see our number there is 14. Hello, 14. So we have a key word here, factors. Now, if you recall, in an earlier lesson, we talked about what a factor is. A factor is a name that we give a number when it's being multiplied by another number, ultimately giving us the product. We could sneak in numbers. We could put 6 times 7 is equal to 42. Therefore, so 6 is a factor of 42. That's how we have to say it, not the other way around. 42 is not a factor of 6. However, if you remember we did multiples, we would say that 42 is a multiple of 6. It's almost like the reverse. Woo! It's like a swing set. Wee! Wee! Okay, just kidding. And then 7, of course, too, is a factor of 42. And then I added my nice little arrow. Very cool. So now we come over here. So what's the best way to do the factors of a number? And again, if you recall from the earlier lesson, we did something called divisibility. I have to sound that out. What a long word. Divisibility. We did 2, we did 3, 5, 6, and I think maybe we did 9. The first thing is we always have 2 factors, and that's 1 and the number itself. So when you think about 1 times 14 is obviously going to equal 14. Well, that makes that statement up here true. So that's a great place to start. How I like to do mine, though, is I always like to put my 1 first. The reason why I kind of do it this way, that way I can kind of match them up. But you also might notice that the next number here is a 2. And the rule for 2, when that means divisibility means that you can divide a number without getting a remainder. So we say that like 4 is divisible by 2 because if you take 2 times 2, that equals 4. So therefore, it works. I would say that 4 is divisible by 2. Because 14 is an even number, and that's the key thing for number 2, is that it ends in 0, 2, 4, 6, or 8. So if it ends in one of those digits, it's divisible by 2, which means you can divide it by 2, which also means there's a factor of 2, because 2 times something then is going to give you 14, which I know you guys are all shouting the answer going, yeah, it's 7, it's 7. I know. You guys are like super smart. See, even the zebra didn't ask her. I'm sorry, Zeke. Zeke didn't even... Oh, okay. He didn't answer it because he was just trying to be humble. What a great guy. Okay, yeah. Now, let's go on to number 2. It says select the numbers that have a factor of 5. Mark all that apply. Mark all that apply. That's right. So, the rule for 5, pretty simple. If the number ends in 0 or 5, then we know that that number is going to be divisible by 5. Here's 5 right here. I saw that right away. Well, 5 times 1 is 5. So 5 is a factor of 5. So that's true. D, you are absolutely dynamic. Woohoo! Yes, look at that. It almost looks like a star. God, I didn't even try that. Woohoo! I am good. Okay, now, 50. Ooh, look, it ends in 0. Remember the rule? If it ends in 0 or 5. So E, you are excellent. Yes, will I be able to make another star? Not in a million years. Although it does kind of look like a nebula, before it becomes a star. Woohoo! Now 31 does not end in 05, so no. Sorry, F. So with no F, we move on to A, 15. Well, yeah, it ends in 5. And 3 times 5 is 15, so A, You are awesome. Yeah. 3, sorry. And then C says 45. Well, of course, 9 times 5 is 45. So C, I like it. C, you're just awesome too. Okay? You get to be like with A. You're awesome. Now, time to move on. Dun, dun, dun. Number 3 says Jackson was making a poster for his room. He arranged 50 trading cards in the shape of a rectangle on the poster. For 3A through 3E, choose yes or no to tell whether a possible arrangement of cards is shown. Okay, I can already tell by the question. This is where we talked a little bit about arrays. So 5 rows of 10 cards. Well, 5 rows makes it sound like 5 times 10. Does that equal 50? It does. So that's a possibility. Okay? So we say yes. Yes, 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 yes. Now 7 rows of 8 cards, if you just know your times table. 7 times 8 does not equal 50. So that's just how it is, you know? That is going to definitely be no. Now I come over here. Ooh, that's not a very nice circle. Come on, Mr. Waara. Okay, looks like another star. Anyways, 25 rows of 2. Wow. Is 25 double? Because I think of times 2, double? 50? It sure is. Yes, sirree. And then 50 rows of 1 card. Okay. Why? Because the equation is just 50 times 1, which of course equals 50. So we have another yes. 45 rows of 5. Oh my goodness, that's going to be like so far above 50. We're going to have to put no. So that's my final answer. Yes, no, yes, yes, no. Okay, now we move on to, it says list all the factor pairs in the table. Factor pairs. That's another way to say that because you have that factor times a factor equals product, like 8 times 6 happens to equal 48. There's one already. So I'm going to go ahead and put that one in there just because I just thought of it. That's the equation. Though the really obvious one is just 1 times 48, right? The identity property of multiplication. That is what it is called. Yes, because it's telling us like identity. The 1 is letting us know it's still a 48. So I have 1 and then 48. Cool. I know that 12 times 4 is equal to 48. So I'm going to put 12 and 4. So I have 2 more. 24 double. That's 48 too. That's why I love that double. So 24 and 2. And then, of course, this is where it comes in handy knowing your divisibility rules. Because your divisibility rule for 3 says when you add the digits up, if that number is divisible by 3, then the whole number is divisible by 3. So 3, if I add 4 plus 8, that's 12. That lets me know that a 3 will go into that number. And it's going to be 3 times 16. That's right. Okay, time for Page Master. Woohoo! Moving on to the next page, and there we are again. Hello there, Zeke. Woohoo! How you doing? Yep. Oh, okay. Good to know, my friend. Good to know. Good to have you here. So let's first look at the word classify. I don't know, that's not a really big word. We should probably know that it means like name, okay? Like when you're trying to name something, you're classifying something, okay? So it says here, classify the numbers. Some numbers may belong in more than one box. Okay, well let's just start with 54 and we'll just go all the way across because it says that it could end up in a different box. Now remember our divisibility rules, okay, with 5 and 9. 5, remember, ends in 0 or 5. For 9, 9 is, remember, is divisible by 9 if when you add all the digits together, it's divisible by 9. And then 6, remember, that's if 2 and 3 are divisible by the number, then 6 will be 2. And then finally, we have, if it's divisible by 2 and 6. Okay, well, let's start with 54. Well, we know that 54 doesn't end in 0 or 5. It does not. I can see that. But a 9, I know that 9 times 6 is 54, so that's pretty easy. So right away, can I put 54 there? No, I cannot because it's only divisible by 9. And it says and 5 and 9. So I come over here. 9 times 6, 54. I just said that. So that means 54 is going to go here. Yeah. Next I have, looks like, is it divisible by 2 and 6? Well, the rule for 2, even number, remember, has to end in 0, 2, 4, 6, or 8. Woo! Okay, and it does. It ends in 4, and we also already know that it's divisible by 6 because we just checked, right? With 9 times 6, so 54 would end up in this box too. Let's move to the next one, 72. 5, not going to happen. Sorry, moving on. If the number isn't divisible by one of these numbers here, then we have to just move on. Here we have 6 and 9. Well, I know that 9 times 8 is 72. Last time I checked. Okay, and then 6, isn't 12 times 6 also 72? So I'm going to say that 72 goes here. Yeah. Now, divisible by 2 and 6? Yes, it is. If it's divisible by 6 over here, it's definitely divisible by 2. So I'm going to go ahead and put my 72 over here too now. All right. So far, 54 and 72 are in a tie of being in the most boxes so far. Okay, maybe it could be like a competition with the numbers. We have 84. Wait a second, 5 again? Nope, sorry, moving on. Is it divisible by 6? Well, that's a good one. Well, I know a 2 will go in there. And a 3, if you were to add the digits 8 plus 4, you get 12. And you know what? 12 is divisible by 3. So therefore, 2 and 3, 84 is divisible by both 2 and 3. And what's the rule? If it's divisible by 2 and 3, it is divisible by 6. How about 9? Well, we have 8 plus 4, that is 12. Is 12 divisible by 9? It's not. And you might want to say, is that really true? Well, think about it. 9 times 9 is 81. Yeah, look at no way that you're going to be able to get another group of 9 in there without getting a remainder. Sorry. So you don't get to be here, 84. So sorry. Now we move over to the last one. 84, are you here? Yes, you are. We just proved that you were divisible by 2 and that you were divisible by 6. So 84, at least you get to be in one of the boxes. Now we come over here to 90. We're almost there. 90 divisible by 5. Yes, it is. And 9, sure. 9 times 10. So 90 gets to be in this box. Now we come over here. I know that 9 is already, but what about 6? Well, 6, it has to be 2 and 3. Well, look at 2 goes into that number, and so does 3, because 9 plus 0 is 9, and 9 is divisible by 3. So 90 gets to be here. Ooh, it's in 2 boxes already. Now, how about over here? Oh, again, 2 and 6. We just did that one. So now 90 gets to be over here. 90's winning. It's in 3 boxes. Okay, the last one, 96. Nope, can't go there. Divisible by 5. 5 is so picky. Only 0 and 5. It makes it hard. Okay. Divisible by 6 and 9? Well, let's see. With 6, it has to be 2 and 3. So let me just check. 2 goes in that number. 9 plus 6 is 15. 15 is divisible by 3. So yes, 2 and 6 would work. How about 9? 9 times something? Well, how about just 9 plus 6? 15? 15's not divisible by 9. Makes me want to check though, huh? Well, if you just did 9 times 9, that was 81. 9 times 10 is 90. You can see it's not going to work. Sorry, 96, you don't get to be in here. And then finally over here, it is divisible by 2. And is it divisible by 3? Yes, because remember we determined it was divisible by 3. So if it's divisible by 2 and 3, then it's divisible by 6. And so 96 would at least get to be in this box. Wow, that's the end of the story. Boy, divisible by 2 and 6 really happened a lot there. Okay, let's move on to the next one. Number 6 says James works in a flower shop. He will put 36 tulips in vases for a wedding. How many? 36. Okay, he must use the same number of tulips in each vase. Keyword there, the same number of tulips. And that's in each vase. This is crucial. Okay, the number of tulips in each vase must be greater than 1. Okay, greater than 1. So I can't just have like 1. I got it. And less than 10. Ooh, there's also a limit. I can't have more than 10 in each vase. How many tulips could be in each vase? I can't help it that when I read a problem like this, it seems like we have equal groups of things. Like here, the same number of tulips in each vase. Okay, so let's just say we have a total of 36 tulips. That number's not going to change. Okay, so this is the number that we're actually using for this problem. And what's important to note is that, look at, we don't really know how many tulips we could put in each vase. There just has to be the same amount in each one. So if we had a vase, we could have 36 vases, right? Put 1 tulip in each vase, except here it says it has to be greater than 1. So we could put 2 in each vase. Well, when I think about that, I'm thinking we're looking for factors. We're trying to find factors of 36 because 2 would be a factor of 36 and that would make that equal group because 2 times something will give us 36. Let's take a look here. So if we did 2, well, 2 times what? 18 gives us 36. So let's find some more factors of 36. Will 3 go into 36? It will. 3 times 12 is equal to 36. So I'm just going to get all my factors now. Will 4 go into 36? Yes, 4 will also go into 36 because 4 times 9. My goodness, 36 is a composite number, but it has so many factors. 5 won't go in there, but 6 will because 6 times 6, yes, is 36. Yes, it is. 7 won't go in there. 8, 8 times something? I don't think so. 8 times 4 is 32. 8 times 5, 40. Nope. How about the 9? Already have it. How about 10? Nope. 11? Nope. 12. Look at, we're working our way back. That's it. That's all our factors. Okay. But now there is that condition. It had to be more than 1, right? But it has to be less than 10. Okay. So numbers it can't be then 18, and we can't have 12. Okay. Because those number of tulips would be more than 10. So what could we have? Let's take a look. We could have two tulips in each vase. That would mean that we would have 18 vases, right? Because 2 times 18 is 36. We could have 3. Yes, because 3 times 12 is 36. We could have 4 tulips in each vase because 4 times 9 is 36. Could we have 6? Sure. 6 tulips in 6 vases. And then finally, could we have 9? Yes, it's still less than 10, which is important. So we could actually even have 9. So we could have 2, 3, 4, 6, and 9 tulips in each vase, and they would add up to 36 tulips altogether with all the number of vases. Now number 7 says, it says Brady has a card collection with 64 basketball cards, 32 football cards, and 24 baseball cards. Yes, yes. He wants to arrange the cards in equal piles with only one type of card in each pile. There we go again. That equal piles, like equal amount of tulips like in each vase. How many cards can he put in each pile? Mark all that apply. Okay, cool. I love that. We have 64 basketball cards, okay? 32 football cards, okay, got it. And we have 24 baseball cards. Very nice. He wants, okay, so we already read that. And we have to have equal piles. See, equal piles. That means you have to have the same number of piles, right? For each type of card in each pile. It's kind of a confusing question when you think about it. But it's like, for example, for the basketball cards, let's just take 2. I can see that 2 is definitely a good factor because 64, 32, and 24 all have a factor of 2. So I could have 2 piles of basketball cards. We'll just say that's basketball cards. We would end up having 32 cards in each pile. Here, now we have 32 football cards. Okay, well 32 football cards means we could still have, what if we took that number and split it in 2? We'd end up having 2 piles of football cards. Football cards, we'll just call that FC. And then if we split that number 2, that would mean we would have 16, okay, in each pile. And then lastly, we have baseball cards. And we have 24. If we divided that into 2 piles, we would have 12. So I'm going to say 2 piles of baseball, and I just put base. Then that means I'm going to have 12 in each pile. So let me see if this met the requirement of the problem. It did say that. It says he wants to arrange the cards in equal piles. I do. 2 piles, 2 piles, 2 piles. Then it says with only one type of card in each pile. That's true. In this one pile, I can't put football cards in with baseball cards. What they're trying to say is I have to have all baseball cards, all basketball cards, and football cards, okay? And I've done that, so I've met the problem. So I can see what we're looking for now. We're just looking for common factors with all 3 numbers. So I'm going to write those out. So I'm going to put here 64, and then I'm just going to list all the factors that it has. 32 and 24. Okay, we know they all have 1. Does it say anything? Could we have 1? He could actually do 1. They all have a factor of 1. They all have a factor of 2. We just showed that. Do they all have a factor of 3? 3 won't go into 64. 6 plus 4 is 10. It's not divisible by 3. 32 is not. However, 24 is. And we need to find ones that they're all going to have that in common. So we'll just keep going. 4 definitely goes into 64. I know that because 16 times 4 is 64. 4 goes into 32 because 8 times 4 is 32. And 24, yeah, 6 times 4 is 24. We move to 5, skip. No 5 there. 6, well, I know 6 will go into 24. Doesn't go into all of these. I know it doesn't go into 32. I go to 7. Could go to 8. Definitely 64. 8 times 8 is 64. We already said that 4 times 8 is 32. And here, 8 times 3 is 24. And look at, and the only other number we have here is 32. Interesting. So we could actually complete this now. So here we have 1. They have that in common. 2. We have the 4, because they all had 4s. And look at that. Ooh, I'm kind of sloppy. No. There we go. 1, 2, 4, and 8. So if I were to color these in, I would do 1, yay, 2, no, sorry, 3, boop, 4, oh yeah, look at 8, wow, 4 correct answers, but not 32. Oh my goodness, this is so much fun. I can't believe it. It's just a blast. Number 8. Yeah. This is the garden club is designing a garden with 24 cosmos, 32 pansies, and 36 marigolds. It says each row will have only one type of plant in each row. It says Ben says he can put 6 plants in each row. He listed the common factors of 24, 32, and 36 below to support his reasoning. All right, well, let me see what he did here. 1, 2, 3, 4, 6, 8, 12, 24. Yeah. What I like to do here on this one is he list them that way because you can see it's matching pair. See how that works? 2 times 12 and then like that. Okay, and then 1 and 24. Whee! Okay, and so 32, 1, 2, 4 times 8. Oh, what happened to 8? Oh no! Ben, you let us down here. Because 4 times 9 is 36, so that one actually shouldn't even be there. We need the 8. 6, oh my goodness, and 6, you can't multiply to get 32. 16 times 2, those two match up. Oh, okay, so he's missing the 8. Because he does have the 4 listed there. He's missing the 8 and put a 9. Oh, okay, I can see. 36, 1, 2, 3, 4. 6 times 6 is 36. 8 times something will give you 36. No, let me see. 8, no. 4, 32, 8, 5. I don't think that one will go in there. 12 times 3 is 36. 18 times 4, no. 18 times 2. Oh, okay, there's the 2. 18. 6 is just listed once because it's the same digit. Oh, so 9. Oh, these two reverse. It's almost like he's missing a 9 here. I see. For 9 times 4 is 36, and he's missing the 8 over there. Maybe you got those switched around. Is he correct? Explain your answer. If his reasoning is incorrect, explain how he should have found the answer. Okay, so we already kind of said that he's not correct, so I would definitely say no. He's not correct. And then it says explain your answer. Ooh, don't you love Common Core? You have to explain why you know. Well, with 24, he's correct. What we're trying to do is we're trying to find that common factor with all 3 of these numbers. Okay, and that's what we were doing in the last problem too. So he could have a row of 1 because they'd all share that factor. And as you can see, they all have 2. They share that factor. But now we kind of run into some issues here a little bit because here he put that the 32 had a factor of 9, which is really 8. And so this one here should have a factor of 9 instead of the 8. So, but either way, still this would work. 1, 2, and 4. What did he say? He said that he could put 6 plants in each row. That's not true. Because here 32 does not have a factor of 6. He said it did. However, 36 does have a factor of 6 and 24 has a factor of 6, but 32 does not. And so his statement, 6 plants in each row is not true. It could only be the most he could put. Is that what he's trying to do? Each row will have only one type of plant. He says he could put a row of 1, a row of 2, or 4 in each row, but he couldn't do the 6. So let me go ahead and put that into words. Okay, Zeke, how'd you do? Pretty good? Yeah? Oh, okay. Hey, thank you for your honesty. See, you were trying to go really, really fast, thinking that you knew the answer right away. So, yeah, maybe next time you can think a little bit longer. Hey, Zeke, good to have you here. I guess we're going to see you in the next couple videos, right? Oh, yeah, no, I don't think you're going to get eaten by a lion here in my math video. Okay, I think you're safe.
This guy's a real comic.
Okay, you guys, I hear the music. It's time to bid farewell, my friends. Thank you so much for coming to my channel. Again, I'm new to teaching 4th grade here with some of these videos. I'm glad that you